All right, LNM insiders, you have asked for the proof, the evidence, if you will, regarding Marshall Masters' claim of Planet X. And so I have with me here a gentleman who is an astronomer in New Zealand. And so, Dave, please take it and let everybody know a little bit about your background, and let's do this.
Hello, Michael, and thank you for having me on. Yes, I'm an amateur astronomer here in New Zealand. I've been interested in astronomy since I was a young teenager, about 35 years ago. I have to say I don't have any formal qualifications in astronomy, but as I say, a lifelong interest. I am with the Tauranga Astronomical Society, where I'm a serving committee member at our local observatory and astronomical society. And I do present talks on a regular basis at the regular public meetings. Yeah, so that's my background in astronomy, and as we'll see, I guess, in this video, as we use the tools, where that interest goes.
All right.
Okay, so I think you wanted to have a look at the object of interest, as Marshall Masters has referred to it in his videos. This one is Blue Kachina and its moon by Marshall Masters, and we'll start with this clip and just play a little bit of it and take a look.
The green arrow pointing down in the middle is pointing out our object of interest, and the one pointing up at the bottom is at a known reflection we call Yogi. Now, watch as they are closing. What we see is that our object of interest, the blue Kachina, does not move like a reflection. Next up is a persistence study, and here you can see that the object is moving down to the horizon very nicely, as it always does. But focus on the last frame in this sequence, and you can see while all the other reflections are gone, our object remains.
Okay, so I'll just pause it there. Now, some interesting things here. This is a lens reflection, and I'm going to go over the reasons why it's a lens reflection.
Okay,
but
you're coming in just a little low, so if you could speak up just a little, please.
Okay, how's that? Is that better?
Much better, thank you.
Okay. Now, this is a lens reflection, and I'll be demonstrating why it's a lens reflection, but you know, Marshall refers to this last frame, and he points out that, hey, you know, it's still there. Well, yes, of course it's still there, because the sun is still there. And we can see this big cloud bank here that's coming in and obscuring the sun. I would have been interested to see the next few frames as well, but conveniently we've actually stopped on this frame, which isn't very helpful. Now, something else I need to point out too is that when we see the sun in the sky, we see what appears to be a great big object, as we see here, but in fact most of this is actually glare. Now, the actual sun's disk is much smaller. It would be like about this size here, but because of the light being refracted through our atmosphere, a lot of the sunlight is actually diffused, so we see this much bigger area. Now, a simple test to actually check to see how big the sun's disk really is to go down to your hardware store and go in and ask for a replacement welding lens for a welding helmet. It would probably cost about $2, and you want to ask for the darkest shade available, which is probably a number 12. If you can get higher, even better, but number 12 is normally the darkest. Hold that up and you'll see that the sun's disk is actually much smaller than the glare that we see here. So let's just back up again and just take another look at what we just saw, and I'll point some things out here. Once again, Marshall has pointed to the object of interest, which he refers to as the blue Kachina. We can also just make out this other one here, which I believe he calls blue bonnet. This one here he calls Yogi, which he acknowledges is a lens reflection. Now, what do we see in this image? We see a great big dark piece of cloud. Would you agree with that, Michael, that is a dark piece of cloud?
Absolutely.
And here we are with this object in front of the cloud. Now, that's an impossibility, because there is no way that you're going to see an object such as, for example, Venus, which can be photographed during the day, as long as it's not next to the sun. I photographed Venus myself. But you're certainly not going to photograph it when it is next to the sun, and you're definitely not going to photograph it when it is behind a thick piece of cloud, as we see here. Now, the other thing that I'd like to point out is that if we remember that the sun's disk is actually much smaller, it's going to be at the central point here, and we draw a line from the sun down here through this object of interest, down through blue bonnet, as he calls it, and down here to Yogi, we've got a perfectly straight line. Okay, now this is more evidence that this is actually a lens flare array. But hey, let's not take my word for it. Let's look at some other images from the Turrialba Volcano webcam, as we see in this image here. Let's have a look. Okay. So this goes back to Tuesday, April 23, 2013. This is 2:12. And let's just run through these images. Now, it doesn't come into view for quite a way, so I'm going to have to step this along. Okay, let me just back up here. Right, now I'm going to go forward again, and just here we start to see this object here coming into view. Can you see that, Michael?
Yes, sir.
Okay, it sort of looks like a blue hand as it's coming into view. Now, that, of course, is because the sun, which is just out of view, is getting lower, and it's shining on the protective dome of the camera. I'm assuming it's in a rounded perspex dome, but in any case it's going to be in some sort of protective housing. And as the sun gets lower in the sky, it's actually shining on that housing, and we're getting a lens flare, a reflection, what I would call an internal reflection on that housing. Now, as I step this forward again, now we can sort of see this rainbow effect around here. Can you make that out there?
Yes, I can.
Okay, so we've got these lines radiating down, and then if I step that forward, now suddenly, I've just gone back, now suddenly I'm just going to flick backwards and forwards here. What do we see? We suddenly see the object of interest, or Planet X, or the blue Kachina, or whatever you want to call it, has suddenly appeared out of nowhere. So I'll step this forward. It's brighter now, and as you can see, it's getting lower as the sun starts to come into view. Now you can just start to see that the sun is on the edge of the field of view of the camera, and so we've got this light shining here. We've got the blue Kachina, or object of interest. We've got blue bonnet, and also we've got Yogi just coming into view here. And again, we can see this rainbow effect down here with the lines radiating away from the sun. So let me step that forward again, and you can see it all getting lower there. But you notice that this whole array remains in a straight line from the sun. And here comes the sun. The other thing that we need to notice is that the object of interest here, as I progress this forward, you're going to see it getting closer to the sun. Now, if this was an object in orbit at 2 times the distance of Jupiter, which is the distance that Marshall Masters claims that Planet X is or was at, I believe he's saying that it's now between Jupiter and Saturn. Well, twice the distance to Jupiter is actually out to Saturn, approximately. So, but we see that it's actually getting a lot closer into the sun there. But the other thing that we notice is that this whole array of lens flares is always in a straight line, including our object of interest. Now, how convenient.
Yeah.
Okay. So this brings us to another problem, is that we've been looking at these images from the Turrialba Volcano webcam, I believe, since about 2010. I have to say I haven't been following Marshall's videos closely, so I'm just going on the little bit that I've been looking at recently. I believe that he's been using these images from about 2010, certainly in the last 3 years. And in all of the images that we see from the Turrialba Volcano webcam, we see the object of interest, Planet X or blue Kachina, is in the vicinity of the Sun. Okay. Now, if we go into Starry Night, and I've got this set up as the top-down view of the solar system, and so here we are looking out to Pluto. This is the orbit of Jupiter in red, out to Saturn. So I'm going to zoom in. Marshall claims that Planet X is currently between Jupiter and Saturn. So we're somewhere between the red orbit here and the brown orbit here, which is Saturn. So we're looking halfway in between. Earlier on, he was saying that it was at twice the distance to Jupiter. So we're looking at out to the distance of Saturn. So what I'm going to do is set this up. So we're simulating our view that we see here. Obviously, we're looking from the Earth out towards the Sun, and we can see Planet X, which is supposed to be about twice the distance to Jupiter. So let's set this up. So what I'm going to do is, let's pretend that Saturn is actually Planet X, because that's twice the distance out from Jupiter, or to Jupiter. So I'm going to have to advance this so that the Earth is actually around on the other side of the Sun. So let me step this forward. Now you can see how much faster the inner planets move around the Sun compared to the outer planets such as Jupiter and Saturn.
Yeah.
They're much slower, aren't they? Okay, let me just make sure this is nice and straight. Okay, so what I'm going to do now is take a line from the Earth, and you can see on the top left-hand corner it says Earth, so I'm on the Earth here. I'm going to take a line out through the Sun and out to Saturn. So we can see that that's pretty much a straight line. Would you agree?
I would agree, yes.
So this simulates looking from the Earth towards the Sun, out through the other side to Saturn, which we're going to pretend is Planet X. Now, the problem that we have is that for every day of the Earth's journey around the Sun, it's going to move in its orbit by approximately 1 degree. Okay, some basic mathematics. We've got 360 degrees in a circle, full circle, and we've got 365 degrees in a year. Now, obviously, it takes 1 year for the Earth to go right around the Sun, 360 degrees. So we've got approximately 1 degree per day of Earth orbit. So this is the time control here, and I'm going to change the units to days, and we're going to step this forward 1 day at a time, and I'm going to step this forward 7 days to start with. So remember, we've got a straight line from the Earth out through the Sun, out to Saturn, which we're going to pretend is Planet X. So here we go. I'm going to step this forward 7 clicks. 1, 2, 3, 4, 5, 6, 7. You could see all the planets moving there.
Yeah.
Let's check that line again and see what's happened. So out through the Sun again, we're taking a line, and now you can see that we've actually moved, and obviously it would be about 7 degrees. It would be slightly less because we have to account for Saturn's orbital movement as well. But you can see that we're no longer looking in a straight line past the Sun out to Saturn or Planet X. We're actually now several degrees out. Okay.
Yeah.
So that was just 7 days. Now let me step back. So we're back to our starting point. 1, 2, 3, 4, 5, 6, 7. So we've got them lined up again. Okay. Now, let's let's take this to the extreme and take that out to 30 days or approximately 1 month and see what happens. Because if we look at the images that Marshall Masters has presented on his website and in his videos, we see a lot of images from the Turrialba Volcano webcam from like January, February, March, April. I've seen some from May. I think I've seen some from August as well. So what happens when we step this forward 30 days? Well, obviously at 1 degree per day, 30 days is going to be 30 degrees, and 3 months or 90 days is going to be 90 degrees, which is going to create some interesting problems. So that's set to 30 days. Let's step it forward 1 click. Okay.
Okay.
So if I take a line now from the Earth looking towards the Sun, as we do in the images, and now you can see that we're looking way down here. Okay. Let's step this forward another click. So that's 60 days or 2 months. And let's take that line. And there's no way that we're going to be seeing Planet X or blue Kachina or anything in the webcam images, because it just would be completely out of our field of view. Let's take this one more click. So it's now 90 days. And now we can see that the Earth is pretty much at right angles from where we started. We're at a 90-degree difference. So if I take this line from the Earth down through the Sun, we're looking at pretty much 90 degrees from where we started. Now it's not quite 90, of course, because of Saturn's rotation as well. But you see the difference that we've now got in the angles.
I do see the difference, and there's going to be some out there who are going to say, well, maybe Planet X is just moving along with the Earth, and it don't work that way, and they should understand that. You notice Saturn and Jupiter, that when they move a lot slower, because they're out further, right, and because they're much bigger. So, assuming Planet X would be where we're told it is, then it would be moving just as slow as they would, wouldn't it?
That's correct. Otherwise, for it to remain in the view of the webcam, as we see in these frequent images from the Turrialba webcam, in fact, to remain next to the Sun, it would actually have to be in a synchronous orbit, mimicking the Earth's orbit. It would have to be at the same distance as the Earth, but on the other side of the Sun. The mass would have to be the same. You could account for different orbits with different mass and so on. But this thing would be rocketing around the Sun in order to keep up with the Earth. Now, remember that Marshall has said that this object is somewhere between the orbit of Saturn and Jupiter. He did say that it was twice the distance that Jupiter is out from the Sun, which actually takes us out approximately to Saturn. But more recently, he's saying that it's halfway between Saturn and Jupiter. So if it was out here, then obviously at the rate that the Earth moves around here, then Planet X would have to be traveling at warp speed around the Sun to keep up. But let's take this to the extreme now. We've gone ahead 3 months or 90 days. I'm going to step this forward 6 months or 180 days. Okay, so 1, 2, 3. Now we've got the Earth completely on the other side of the Sun from where we started. We were over here when we started. Now this is an extremely important point that I hope people will take on board. People always say, well, there are different camps on Planet X as far as where it's located. Some people say it's next to the Sun. Some people say it's in Orion. Some people say you can only see it from the South Pole. And I'm going to come back to these points as well because they're all nonsense anyway. But the important point is that, okay, if Planet X was next to the Sun, and it's on the other side of the sun, people say you can't see it because it's on the other side of the sun, right?
Yeah.
Well, where were we 6 months ago, and where will we be in 6 months' time from now? On the other side of the sun.
That's right.
Opposite direction. Now, I've just demonstrated in Starry Night that, 6 months ago we were over here, and now we're over here. Another 6 months we're going to be back over here, So to say that something is on the other side of the sun, well, okay, well, in 6 months we'll be on the other side of the sun as well, and 6 months ago we were on the other side of the sun. So here we are, we're now on the other side of the sun from where we started, and if we look back towards the sun and take a line out, we're pointing in completely opposite direction because our planet X is over here.
And again, people should keep in mind that this object wouldn't move around the sun as fast as the Earth would.
No, and what I'll do now is I'll actually run this forward real time, and we can actually see that. So let me just get these so they're easy to see. Of course, our inner planets are all sort of really close together until we get out to Mars, and then there's this big gap. But let me, okay, real time. I'm not going to see anything, of course. Let me change this back to days, and we'll run that forward. So you can see Mercury, Venus, Earth, and Mars are heading around at quite a pace. And excuse me, as we get out to Jupiter and Saturn, obviously they are much slower. But if we imagine following an object that's on the other side of the sun, we can see that as the Earth is going around the sun there, then the object would have to be going around at a great rate. It would be traveling at warp speed around the sun. And here we go, Jupiter and Saturn there. So that demonstrates the problem. And of course the insurmountable problem is that, as I say, 6 months before, 6 months later, we're actually on the opposite side of the sun from where we were or where we are or where we're going to be. So you can't say that something is permanently next to the sun, because it just doesn't work that way. You've got 1 degree of difference approximately for every day that the Earth orbits around the sun.
Right, and if you had something of that mass going warp speed around the sun, I would have to guess we would know about that.
Yeah, well, I mean, the mathematics just don't work anyway, and I'll be straight up with you, and I'm an amateur astronomer. I've got far more skilled people that are on the team that I work with. I have my channel, Dazza the Cameraman, on YouTube, but I work with a great bunch of guys, including Bill Hudson from. He set up the website called 2012.hoax in the lead up to 21st of December, and obviously after that passed without event, he set up another one called Cosmophobia. And on my Facebook page, Voices of Reason to Explain X, we've got some great guys, including Chew Bird, Scott Ferguson from Astronomy Live, and several others who are much more skilled in astronomy than I am. And so, they would give a good answer about the mathematics of the mass and speed and all of that. But I mean, we can use the planets that we have in our solar system as a guide anyway. And we just saw how they move through the sky. Now, another point I'd like to make while I'm here, you can see Ceres there. We've also got minor planets within our solar system that we know about. Pluto has been demoted from a planet to a minor planet. The reason being, or one of the reasons being, is that some of the objects are actually larger than Pluto, so they would be more of a candidate as a planet than Pluto should be. So yeah, was the data on Ceres there. Yeah, Ceres has a radius of 476 kilometers there, so it's a reasonable piece of rock. and that's within the orbit of Jupiter.
Yeah. Okay. And again, I just want to stress that I appreciate you and your team, as a matter of fact, for what you do. And it's not about that you're out here trying to debunk things. You're just trying to give people the truth, and I appreciate that.
Thank you. I appreciate that too, Michael. And let me. What was that? I was looking at one of the images from Marshall's website. This one here. No, I've opened the wrong one. That's the one we're going to demonstrate. That this is from Marshall's website, where he's actually pointing to the object of interest here. I don't know if yes, maybe we can see the date on there. That's 2014 on the 23rd of January from Turrialba. Okay. Now, let me open this in good old Paint, nice and basic. And I'm just going to go new file. So we've got a blank canvas. Paste from, this is the image. So I'm just going to move that so we've got a bit of space around it. And let's just do a little exercise here. I'm going to draw some lines on this. We can see that the sun is just out of view. Can you see that, Michael?
Yes, I can.
Can you see these rays coming down from the sun?
I sure can.
Okay, so let's use those to draw some lines so that we can get the central point of the sun, work out where it is just out of view. So would you agree with that as I've drawn those lines? Are you there? You've just dropped out.
Yeah, I'm here.
Yeah,
I agree.
So we've got that. Let's draw some more lines from corner to corner, which will give us our center. Okay, so we've got dead center there. Let's put a nice big point on that. Okay, now let's draw another line. I'm just going to zoom in so I can get this really, really accurate, because I wouldn't want to not be accurate and give the wrong impression. So I'm going to draw a target line here. So we've got our object of interest, or planet X, right in the middle of the crosshairs. Let me just undo that one and do it a little bit more accurately. There we go. And back to that. So you would agree with that?
I will.
Okay. Now let's take a line from the center of our photograph up towards the center of the sun. Right through planet X. Now, what does that tell me? That tells me that this is a lens flare. Now, this little exercise will work fairly accurately most times. Sometimes it'll be slightly off center, but as a guide, it works pretty well.
Mm-hmm.
So this is further evidence that we're just looking at lens flare. I mean, you can see part of this lens flare here as well.
Yeah.
And you know, all in a straight line with the sun.
And there's even pictures where this object actually, clouds by it, but it seems to stay on the other side of the clouds, the visible side, which wouldn't happen if it wasn't a lens flare.
Like this one here.
Yeah, exactly.
This is actually unfortunately I haven't got this video loaded.
And see, this should really be all the evidence anybody would need right there. I mean, that about that amounts to it all. I mean, the proof is in the pudding.
Yeah.
I mean, if even the sun's not shining through the cloud like that,
Yeah.
But this object is. Mm-hmm.
The sun is actually
Above,
you
yeah.
can actually see the light shining down here, and that's why we're seeing the lens flare. Now, there's a very simple test that can be done in these images that people take with their cameras, their cell phone cameras, and so on. I call it the finger test, and it's very simple. All you do is that when you're filming something and you can see an object next to the sun, you simply extend your arm out, hold your finger up, and put it between the camera and the sun. Now, when you block out the sun with your finger, obviously if the object that you're looking at is a real object, it's going to remain. But if you block out the sun with your finger and the object disappears, then obviously it's lens flare. Now, the second part of the test is to put your finger out in front so that when you're looking at the screen on your camera, you can see that you're moving your finger in over where the planet X is, or second sun, or whatever you want to call it. And if you find that second sun is now over the top of your finger, obviously it's not real. And I can send you the links to some very good YouTube videos that demonstrate that very well. They've been used to debunk a lot of second sun planet X images.
That would be great. Now what I'll do is any links that you send me, I'll put in the description with this video so people can go and check it out.
Right. Okay. Now let's have a look at these images here as well. Again, this is an example of planet X, blue Kachina or whatever, in front of the clouds. I've only got a few images on this one. Now you can see that it's in the clear in the sky there, but as I back up, again we've got that problem that we've got some cloud here. So there it is.
And there it is. Yeah.
And there's no way that you would see an object like that. And even if this was Venus, you're never ever going to be able to film Venus when it's next to the sun like that. If it's
You're certainly not going to be able to film it through the cloud. No. Not thick cloud like that.
And once again, we see this lens flare array. If we take a line from the center of the sun down here, it's always in this line. And the other problem, of course, is that as we look at the images, the object is actually moving away from the sun. It depends on the motion of the sun, angles and so on, but we're seeing this object moving closer or further away, and you're not going to see that amount of movement over the period of minutes or hours as we can see from our Starry Night demonstrations.
That's right.
Now, there's an interesting point. I was sort of reading up on some of Marshall's articles last night, and I was looking at this one here, which goes back to 2010. Australian survey buoy anomalies offer new evidence that planet X is approaching from the south. Hello? I think Marshall Masters has been telling us that planet X is next to the sun. It's coming in from the direction of the sun. So this one came as a real surprise. He's got all this evidence here that, as he says here, a heated debate in the Planet X community focuses on where Planet X is approaching from. Many believe it is near or moving along the ecliptic in the direction of the sun, that is the plane of our solar system. Others, such as ourselves, have always maintained it is approaching from the south. Those who believe it is moving near or along the ecliptic in the direction of the sun offer an evidence, cell phone photos, and spurious SOHO image anomalies. Our position has always been that this dubious imagery misses one simple point. If so, Planet X, which is most likely has its own magnetic field, would already be interacting violently with our sun, which is at this time so quiescent that NASA even said that it is the quiet before the storm. So we seem to have a complete reversal on what Marshall Masters has been saying, back in here we are looking at 6th of June 2010, and he was saying that from, ourselves have always maintained that it is approaching from the south. And, we get into this whole discussion about, it's below the ecliptic, so you can't see it. Well, I think I need to explain a little bit about below the ecliptic. Okay?
Okay.
Now, we're back into Starry Night, and we're actually looking at the view that was in images that were discussed in another one of Marshall Masters' videos, Planet X Orbital Analysis, or some similar name. And he presented some images that were taken by a Jorge Urena, I believe his name is pronounced George Urena, when he was on a flight from or to Peru. And we've got Starry Night set up at the same location, 12.2 kilometres up, or about 37,000 feet. It was on May 27th, let me bring that back one day, and it was at 6:29 according to the images. We can look at those further if we get time. But anyway, here we are looking at the sun, and we've got Mercury, Jupiter, Venus in the sky. And we see this green line. Now let me just explain what the ecliptic is. The ecliptic is the apparent path that the sun takes as it travels across the sky. Now, of course, the sun doesn't travel across the sky. It's the Earth rotating on its axis once every 24 hours that gives the illusion that the sun is crossing our sky. But there's this imaginary line that we call the ecliptic, and so we're looking towards the sun. And also it is pretty much the same as our orbital plane. You'll notice that if I zoom in on the planets, we can see that the planets are within a few degrees of the ecliptic, and that's always the case. We can see Mars down there is very close to the ecliptic as well. Okay, so this whole business. Let me turn the daylight off so we can get a better view. So now we can see the stars that we would see in the night sky. If the sun suddenly went out, we would see these stars. This is the horizon line down here. Remember, we're 12 kilometres up on an aircraft at the moment. Okay, so there's this myth out there that, you can't see Planet X because it's below the ecliptic. Well, here is the view from near Peru, and I'm going to zoom out here, and let's bring it this way first. So this is like a fisheye view of the sky. So we've got the sun over here, and so that would be its path across the sky. Okay, so this is above the ecliptic. So if we're looking north, and let's just pan around, and this is below the ecliptic, and we can actually see from this location, we can see all the way down to the south ecliptic pole. All right, so that means that we can see all the way below the ecliptic, all the way down to the south ecliptic pole from this location. Now, I'm in New Zealand, so I'm in the southern hemisphere, and that means that my view, I see the whole of the southern sky. Obviously, I can't see it all at once at any time because of Earth rotation, but through the period of 24 hours, we can see the whole of the southern sky. Obviously, part of that's going to be during the daytime. But my point being is that from here in New Zealand, I can see all the way to the south ecliptic pole. And you don't need to be at the South Pole to see the South ecliptic pole, because, well, a good example is you're familiar with the Northern Pole star, Polaris?
Yes,
okay,
I am.
well, that is right on the North ecliptic pole. So you can see all the way above the ecliptic to the North ecliptic pole, and in the same way, because I'm in the southern hemisphere, I can see all the way below the ecliptic to the south ecliptic pole. So if anyone says to you, well, you can't see Nibiru because it's below the ecliptic, they don't know what they're talking about. It's just, okay? In fact, most people are familiar with the constellation of Orion. Okay, can you see Orion there? Just
Yes, I can.
this way.
Yeah.
Now, I'm in the southern hemisphere, so Orion is actually upside down in my view, but this will be the familiar view of Orion here. So we can see Orion's belt, and we can see the sword hanging off his belt there. Okay. Now, whereabouts in relation to the ecliptic is the constellation of Orion? It's below the ecliptic. And we have no problem seeing Orion, you know?
Yeah, and you know it's you make a good point, because through the years, I don't know how many times I say, well, why can't I see it? And the excuses I get is, well, it's below the ecliptic, so you're not going to be able to see it. But people in Australia are filming two suns in the sky, and then I would be told, well, it's infrared, so you need a special lens to see it. And I'm thinking, but people are getting pictures of two suns with their cell phone cameras, but I need an infrared camera so I can see it. I mean, you know, it's just one excuse after the other, and it just gets so ridiculous.
Yes, well, that's right. I mean, the arguments contradict themselves. You can't have it both ways. You can't say, well, hey, you know, amateur astronomers can't see Planet X because you need an infrared telescope. Oh, here's my picture of Planet X that I took on my cell phone camera.
Yeah, and what the, you know, and I think a lot of these people understand what they're actually taking pictures of, and they put it out there anyways, and that bothers me.
Now, there's a common misconception about brown dwarfs that I think that we need to dispel right here, and that is that people often say, you know, if I say to them, well, if Planet X is within our solar system, why can't I see it? And as we've just said, they'll say, well, you need infrared, you can't see it unless you've got infrared, you know. It is true that we image brown dwarfs in infrared. There's a very good reason for that. It's because they are so far away from our sun that they don't reflect any visible light like the planets do. Now, the only reason that we can see the planets in the sky, and let's just take a quick look at the planets that we can see with our naked eye. We can see Mercury, Venus, Mars, Jupiter, and Saturn with our naked eye. And that is simply due to reflected sunlight. You've got the sunlight shining on the planet, bouncing off, and coming back to our eyes so that we can see them with the naked eye. Now, with a brown dwarf, it's so far away from the sun that it doesn't reflect any visible light. And that is why we have to image them in infrared. So just how far away is the closest brown dwarf? The closest brown dwarf to us, to our sun or to the Earth, is 6.5 light years away. Now, by comparison, our nearest other star, and I say other star because the sun is, of course, a star, but aside from the sun, our nearest other star is 4.3 light years away. And, you know, the nearest brown dwarf is actually further away than our nearest star. Now, the actual nearest star to us is Proxima Centauri, which is about 4.3 light years away. You can't actually see that one. Most people are familiar with the name Alpha Centauri. And Alpha Centauri is part of a star system, Alpha Centauri, Beta Centauri. They are visible. In fact, if you they're one of the two pointers to the Southern Cross, which people in the Southern Hemisphere are well familiar with. Now, if you look at that star, Alpha Centauri, it's actually two stars, but you need to look through a telescope to actually be able to separate them. So they're the visible ones, but as I say, Proxima Centauri is actually the closest one, but you can't see it with the naked eye.
So basically then, if a brown dwarf star did come within the parameters of Jupiter or Saturn, sunlight would then reach it, and we would be able to see it. Absolutely.
Would be a naked eye object, and, you know, there is just no way that a brown dwarf could be within our solar system and not be detectable, you know. It doesn't have a Star Trek cloaking device or anything like that. It's going to reflect visible sunlight. You know, the planet Mars is a very dark red color, and it shows up nice and bright in our sky. In fact, you know, in the recent months, it's been particularly bright because it's been very close to the Earth and its orbit. But again, you know, again, I make the point that we can see Mercury, which is very close to the sun. You'll see it in the early in the morning sky just before sunrise, or in the early evening sky just after sunset. Venus, of course, is the very brightest object, very brightest star-like object in the sky. Jupiter is the next brightest, and Saturn is the one that's furthest out that we can see with our naked eye. Now, an important point is Pluto. Now, Pluto is a tiny little piece of rock that's been demoted as a planet. And, you know, I've imaged that through a 14-inch optical telescope. You don't need infrared to image Pluto. Now, Pluto was officially discovered in, I think it was 1931, if I remember correctly, using ordinary optical photography. And it was discovered when the photographer, he had to sit down and manually flick backwards and forwards between photographic images to see if any of the stars, or you know, apparent stars, actually moved. And if he had a star that moved, then obviously it wasn't a star, it was a planet. And so that's how Pluto was detected. And actually, when they officially discovered it and they calculated its orbit, and then they checked back on previous images using the data that they were able to calculate, they actually discovered that they had imaged Pluto as early as 1915. And that's just through optical photography.
Okay. All right, fantastic. And you know, and this goes without saying. I mean, this whole Planet X thing has been swung around for quite a while. Let me ask you this: what is your opinion on the whole Zachariah stitching? And then I get some who come at me and say, "Oh, the Bible prophecies say that this is happening," and of course I interpret it a little different. I don't see where it says anything about some giant planet called Nibiru coming, but you know, people do try to pull that argument on me, and you know, I've always been one who wants proof, and that's why when you contacted me, I said, hey, you know, if anybody is willing to prove something to me, I'm always going to give them my time. So I appreciate it.
Right. Okay. Well, as far as Zechariah Sitchin is concerned, you know, I have to say that I haven't studied his works. His name pops up in the discussion. But, you know, there are all sorts of people, excuse me, all sorts of people making all sorts of claims about things. You've got Nancy, leader from Zeta Talk, making her claims as well. You've more recent.
Oh, that woman, let me tell you, you know, she won't come on my show because I told her that I'm not going to give her a free pass. I want proof. I'm going to question her good. And so she won't come on, but I had just recently, I think it was your channel, I recently come across a video where, you know, back in 2003, she said, I think it was 2003, Planet X is coming, everybody sacrifice your pets, spare them the misery. And, you know, she even said that she euthanized her own puppies.
Yes.
I mean, that's just, you know, Big Pharma, what have you done?
That was in 2003, and here we are, 11 years later, and we're still waiting for this thing to arrive. We're still waiting for the pole shift that people are predicting. And that's another interesting thing, is that there are a lot of people out there saying that the Earth has shifted on its axis. No, it hasn't. It has not shifted on its axis. Hang on, let me qualify that. Yes, the Earth shifted on its axis following some major earthquakes, such as the Japan earthquake.
And the Haiti too, I believe, moved it a
Yeah,
little.
but I mean, how much movement are we talking about? As I recall, I think with the Japan earthquake, we were talking about between 4 to 10 inches. Let's assume worst case scenario, it shifted 10 inches on its axis. Well, just how much pole shift is that? Well, 1 degree of pole shift would be 111 kilometers. You work out how many inches are in 1 kilometer, let alone 111 kilometers. And when you work out the amount of pole shift that 10 inches is, I can't remember how many zeros go after that decimal point, but it's quite a string of zeros. You're talking about a tiny, tiny fraction of 1 degree. And, the proof is in the pudding. We were talking about Polaris, the northern pole star. Well, Polaris is a good a marker as any, as long as Polaris is still the northern pole star, and it's not right on the northern pole. It's actually 2/3 of 1 degree away, but it's close enough. As long as it's still 2/3 of 1 degree away from the northern celestial pole, northern celestial pole, then that proves to us that there has been no significant amount of pole shift. Now, people often confuse between magnetic pole shift and axial pole shift. That is the axis that the Earth rotates on. And then there's the whole thing about precession. The Earth does do a wobble, which takes about 26,000 years. In 13,000 years, or half of that, Polaris certainly won't be a pole star anymore. Back in the days of the pyramids, it was another star called Thuban. Okay? But, the other problem is that as any astronomer, any amateur astronomer who has a go-to telescope will tell you, go-to telescope, it's got a computer controller on it, and you can select from the database the object that you want to look at, and then you go and push the go-to button, and the telescope, assuming that the telescope is set up correctly, it has to be aligned correctly when it's set up in the first place. But assuming it's set up, as soon as you push the go-to button on the object that you've selected, the telescope will automatically slew and go to that object. Now, if the Earth had shifted on its axis, then that simply wouldn't work. And then people will say, "Oh, but the powers that be have changed the data, they've updated the positions and all that sort of thing." Well, that would be fine with a telescope that's online, but most of the telescopes out there are standalone. They're not connected online at all.
Very good point. And when people talk about pole shifts too, I mean, when it comes to that, it's like we don't need some big celestial body to come through space to cause that. I mean, I think it's the Earth has gone through these cycles before, so sure, one day it probably will happen, right?
Well, there would have to be something major to cause an axial pole shift.
Well, like a major earthquake of some sort. Couldn't that do it? I mean, like a global earthquake?
Well, the Japan quake, what was that, magnitude 9? 9, wasn't it, if I remember?
Yeah.
That's the biggest earthquake in recorded history, was a magnitude 9.5. And, that certainly didn't shift the Earth off its axis to such a significant degree that the positions of the planets and the sun and the moon and all of that shifted.
So, in your opinion, what would it take for an Earth pole
Oh,
shift?
it would take something like a planet coming through and either, well, obviously, if it hit us, it would be all over anyway. But if it
Yeah.
came through and affected the Earth in such a way, And people will be screaming, saying, but Planet X is doing that. No, it's not, because there is no Planet X within our solar system. Let me qualify that again. There is no brown dwarf within our solar system. This term Planet X is used of an as yet unnamed planet. For example, Pluto was once referred to as Planet X. And then when it was, officially discovered and it was given a name, it was no longer called Planet X. But in terms of something like a brown dwarf, which is a massive object, again, I go back to the point that if we can detect Pluto, a tiny little piece of rock, with an optical telescope, and being so far away, then we would have no problem at all detecting a brown dwarf within our solar system.
See, and I always thought that too, and I used to argue with people and tell them, you're telling me that something the size that you claim it is can be next or behind our sun, and we can't detect that? I just don't believe it. And then, of course, I'd always get, well, they're not going to tell us. And okay, maybe if something like that happened, they wouldn't tell us because they wouldn't want everybody, because there's a lot of crazies on this planet, let's face it. But all in all, they wouldn't have to tell us. I think that, people like yourself would be detecting this.
Well, yeah, well, that's right. And, there are many, many thousands of amateur astronomers all around the world. And, just check out on Facebook the number of astrophotography pages that are out there. You can check out the fantastic images that amateur astronomers are taking of the night sky. And there's just no way that could be covered up,
Well, the next comet that comes through and everyone makes noise about it, you're my guy. I'll be calling you.
Actually, that raises a good point, because a lot of comets and asteroids are actually detected by amateur astronomers. Comet McNaught, if you look up Comet McNaught, you'll find that there's actually a whole bunch of them that a serious amateur astronomer has detected. So he's got quite a number of them named after him. So.
Yeah, and I would be more worried about a comet or an asteroid, if I was going to worry at all, before I would worry about a planet coming in or a brown dwarf star, because if that happened, it'd be lights out anyways. So I don't think you'd have too much time to think about it.
Again, it would take an impact to actually cause a catastrophe for the Earth, because back in 1910, Halley's comet visited, and on the 19th of May 1910, the Earth passed through the end of the tail of Halley's comet. And in the lead up to that event, the fearmongers are nothing new. Back in 1910, they were around as well, and they were selling comet pills to ward off the effects of the cyanide gas that was going to be in the tail of Halley's comet that was going to snuff out life on Earth. But hey, if you buy my comet pills, you'll be okay. And on the 19th of May 1910, the Earth did pass through the end of the tail of Halley's comet. And what happened? Nothing. We weren't poisoned with gases. We weren't bombarded with meteors. We weren't invaded by triffids either. So it's just nonsense. Oh, and the other thing is too that we only tend to hear about the comets that may be visible, and obviously Comet Elenin was a fizzer. Comet Ison was a fizzer. It was a real non-event. But at any time, there are actually a couple of hundred of comets within our solar system at any time, but we don't hear about most of them.
Yeah. Usually we hear about them after they've passed, in many cases. So, okay. anything else that you would like to point out here before we finish up? If
Well,
there is
I'm
anything
sure that
else?
there's plenty that we haven't covered, and no doubt I will be thinking afterwards. Oh, I should have mentioned that. But I mean, there's so much to cover. There are so many questions, but no doubt there'll be some comments on the video, and people are welcome to post their questions, and I don't know, maybe we can do a follow up sometime. Um,
Absolutely, and I would say this to anybody, in my opinion, this is just unarguable. I don't see how you can argue. I mean, it's been proven without a reasonable doubt that it is a lens
yeah,
flare, and that was really my goal, and all the rest is just a bonus. I mean, people take that red pill and stick to the truth, stick to things that you can prove, and stop going with the fantasies. I mean, it's like people just, it's like they get so upset if something's not going to be endangering their lives. We've got so much going on this planet right now. Worry about what's going on here on the ground before you worry about some brown dwarf and some Anunnaki aliens coming to enslave us for the gold. I
yeah,
mean, it's just
absolutely. I think people should be more concerned about things like climate change, and I mean, my views on climate change is that it's not caused by any Planet X or brown dwarf. It's caused by us. It's caused by industry. It's caused by deforestation. We're clear felling rainforests. We're actually changing the climate, and the long term effects, I think, are quite frightening.
Yeah, I would agree with that. I just, for me, it's like they often try to blame the SUVs and things like that. Now, I will say, yeah, industry certainly plays a role, and obviously we're not doing much as far as polluting the air. We're definitely polluting the air and the water and things like that. But when it comes to climate change, I think that has a lot to do with the rainforest, as you mentioned. And then, of course, there has been geoengineering as well. And I don't know if some speculate that they're trying to find ways to buy us more time. But I think when you play with Mother Nature, nothing good could come out of that. So I think the what we need to do is stop destroying what we have here. We need to leave these rainforests alone. Matter of fact, add to them if we could. And certainly stop with the oil spills and these nuclear power plants, and because all this is playing a role.
Yeah.
Absolutely.
Yeah. Okay. Well, I guess in conclusion, a couple of very important points that we've brought out in this discussion is that people need to remember that for every day for every day that goes by, for every day that the Earth orbits the Sun, we're approximately 1 degree further around in our orbit. So if we're looking at an object next to the Sun, then in 30 days' time it should be approximately 30 degrees difference from where it was. And obviously, the key point is that in 6 months' time, we are on the opposite side of the Sun from where we are now. And the other point, of course, is that we can see all the way down to the south ecliptic pole. You don't have to be at the South Pole to see the right down to the South Ecliptic Pole. And if a brown dwarf was within our solar system, we would see it.
Absolutely. Well, Dave, I appreciate you doing this, and we'll definitely do a follow-up. And I do have you as a guest tomorrow night on Late Night in the Midlands, and I'm looking forward to that. And I guess that's it, but I would like you to give out any websites or YouTube channels or anything that you'd like to get out there before we say
Okay, thank you,
goodnight.
Michael. My YouTube channel is Dazza the Cameraman, and I also run a Facebook discussion page called Voices of Reason to Explain X, VORTEX. I'd also like to give a shout out to Cosmophobia, which is also on Facebook, and there is also a website, cosmophobia.org, which is run by Bill Hudson. So it's well worth checking out. There's some great links on there. But yeah, I mean, certainly check us out on Facebook, on VORTEX. We'd love to see you there.
Okay, great. And I do want to also say thank you to Peter Kling and Alfred Weber because they have also brought you to my attention. And I appreciate that. And so, Dave, thank you. And everybody, keep supporting us over here at Late Night in the Midlands because all we're out for is the truth. Nobody is too popular, nobody is too big. We just want to get the truth out. For us, it's not about books or CDs, it's about the truth. And so, with that, folks, this has been an LNM Insider video. I'm Michael Vara, and it has been verified.